All right, we started talking about cyclohexane chair conformations in class yesterday, and I wanted to spend a little bit of time working through how to solve some problems, spending some time how to draw these conformations, making sure that we're in good shape as you work through the problems that you're working on for tomorrow. All right, so we're going to focus on drawing cyclohexane chair conformations. Our goals are going to be accurate 3D drawings. We want to identify the more stable of the two different chair conformations, and we want to be able to convert from perspective drawings to chair conformations. All right, so the first thing we're going to do is focus on drawing the carbon skeleton for the chair conformations. All right, so draw the carbon skeleton. All right, and the key thing when you're doing the carbon skeleton for these chair conformations is that you're going to draw 3 pairs of 2 parallel lines for each of your chair conformers. All right, and we want to be able to draw both ring flip conformers. All right, and it's going to be 3 pairs of 2 parallel lines. All right, Klein has a strategy for drawing this in the book. I'm going to give you a different strategy. Whichever one works for you is fine. It does not matter. And again, everybody has their own strategy. Find one that works for you so that you can get structures that look good and that you can draw accurately and quickly. All right, so if we're going to do the parallel line game, all right, so if you draw 2 parallel lines like that, all right, and I'm going to use different colors. Hopefully the red and the blue will show up reasonably well. Then you draw 2 other parallel lines like that. And then finally, the last 2 parallel lines like that. That gives you one of the chairs. All right, and then when we do the ring flip, right, if you number the atoms in the ring, 1, 2, 3, 4, 5, and 6. 2 and 3, if you're looking at your model, are close to you. 5 and 6 are far away. All right, so hold your model and look at it. 2 and 3 are going to be the ones that are going to be the closest to you. All right, and 5 and 6 are the ones that are farthest away. When you do the ring flip, grab a hold of carbon 1 and carbon 4. Take carbon 1 and move it down. Take carbon 4 and move it up. All right, so 1 comes down, 4 goes up. And then what happens when you draw the cyclohexane chair is that you have to draw it in a different orientation. So if we're going to do the parallel lines, the black lines are going to be like that. All right. The blue lines are going to be like that. And the red lines are going to be like that. All right, and again, now we have carbon 1, 2, 3, 4, 5, and 6. And again, these are close and these are away. All right, and so that's what you should be able to do after you practice doing this. Draw both of these different chair conformers and be able with your model to go back and forth. Okay, so practice that, make sure you can do it quickly. All right, number 2 is we want to be able to recognize axial and equatorial positions. Axial are usually the easy ones to spot. All right, axial, they're either straight up or straight down. When a vertex comes together that points up, the axial goes up. Vertex comes together that points down, axial goes down. Right? So those are usually pretty easy to spot. Equatorial. Those are around the center of the ring, and they're parallel to 2 ring bonds. Right? So they're around the center parallel to two ring bonds. All right, we'll show what that means in a minute. So let's just draw the carbon skeleton. All right, we're going to draw it for both of the chair conformers, right? And let's just draw in the axial positions. So when the vertex comes together pointing up, the axials are going to be up, right? Vertex comes together pointing down, the axials are going to be down, right? We can do that on both of the structures. All right, those are all of the axial bonds, right? You can see that we have 3 axials pointing up, we have 3 axials pointing down. All right, on both structures that's true. All right, now let's focus on what's going on with these equatorial positions. All right, so the equatorial positions, again, they're going to be parallel to ring bonds. All right, and so what I want to do is use some color. We'll use color based on what it looks like up here. All right, so the black bonds, these are the 2 equatorial positions that are parallel to the black bonds in that structure above. All right, and over here we can do the same thing. So parallel to those black bonds are going to be that one and that one. All right, now let's parallel to the red bonds up here. All right, so that's going to be parallel to that red bond is going to be this one, all right, and that one. The red bonds over here, it's going to be that one and that one. All right, and then parallel to the blue bonds, right, it's going to be over here, that one, and that one, and over here, that one, and that one. Okay, so we need to practice so that we can do this quickly and accurately. It's going to take a little bit of time, but hopefully you'll get to the point where you can draw those out pretty well. All right. Okay, so practice that. What I want to do now, I'm going to erase, and then we're going to focus on up and down, cis and trans, and actually doing ring flips. All right, so let's try to recognize up and down, cis and trans. Because this is related to what you're working on for your homework. All right. So the key thing here is that each carbon in the ring has one up bond and one down bond. Okay? And we just need to be able to recognize which is up and which is down. All right, so let's draw the following molecule. All right, so we're going to put methyls in a bunch of different positions. All right, so actually let me draw. Sorry. Here's what I'm going to do. Let's put a methyl there, 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 and there. Okay? So what you should be able to do is go around this ring and look and see which of these methyls are pointing up and which are pointing down. And it often is helpful at each position that you're looking at to draw in the H's, because that will highlight, for some of them, what's up and what's down. All right, so if we work our way from right to left, if we look at this methyl group, that H is clearly up axial, so this CH3 must be down equatorial. That methyl group's pointing straight down, so that's down axial. Methyl group here is pointing straight up, so that one's up equatorial. And the methyl furthest to the left, if you look there, the H is clearly pointing down, so that methyl is up equatorial. All right? So the other thing that's important here is that we should be able to use this to label cis and trans. All right? So cis, both groups either up or down. Trans, one is up, one is down. Okay, so if we look at these two methyls, those are both down, those are cis, right? These two methyls over here, those are both up, those are cis. If we look, for example, at those two methyls, we have one up and one down, those are trans. All right, cis and trans has nothing to do with axial or equatorial. It only has to do with up or down. Okay, so now let's look at what happens when we do a ring flip. So 4. Ring flips. Okay, when you do a ring flip, it's really important to understand what changes and what doesn't change. Right? When you do a ring flip, up bonds do not change to down bonds. Up bonds stay up. Down bonds stay down. Cis stays cis. Trans stays trans. The only thing that changes when you ring flip is axial goes to equatorial and equatorial goes to axial. All right? So let's write that down. All right? In ring flips, we do not change up or down bonds. We do not change cis or trans. We do change axial to equatorial and equatorial to axial. All right? That's the only thing that changes when we do a ring flip. All right? So let's look at the following molecule. All right, so we're going to have a methyl group and a bromine. All right, so make that model. All right, so I've got that model made right here, right, where I've got a methyl group and I'll hold it closer. So I've got a methyl group axial, right, and I've got a bromine group equatorial, right, and the way you're looking at it now, they're on the carbons that are away from you, okay? So we've got a methyl that's up axial, and we have a bromine that's up equatorial, so this is a cis compound, all right? And so now we're going to ring flip, okay? And we're going to use the strategy that we talked about in class and that we just talked about earlier in the video, where we're going to have that carbon go down, that carbon go up. All right, and if I do this right, both bonds will stay up, but bromine will go axial and the methyl will go equatorial. All right, so if we hold it like this, right, we're going to take this carbon here and move it down, and then the carbon opposite it and push it up. Right, and if that works, we'll see how we do. All right, we're going to get, straighten it out, the bromine has now gone axial and the methyl group has gone equatorial. Okay, so let's draw what just happened there. All right, and again, if we number this the way that we've been numbering it, methyl is on carbon 5, bromine is on carbon 6. Right, so now bromine is going to be up axial, and the methyl is going to be up equatorial. Right, and we still have a cis relationship. All right, so I want to do one more thing just to practice what you're doing for your problems for tomorrow, which is when you have a perspective drawing, what happens to turn it into a chair. All right, so let's look at this molecule that looks kind of similar to what you're working on for homework. Right, so the question would be convert this into the two chair conformations and figure out which one is most stable. Right, so let's draw, and again, it doesn't really matter, you're just going to pick which one you want to start with. It might help if you want to number things just to make sure that you're being consistent, so we can just number this 1, 2, 3, and again, we'll stick with the same way that we've been numbering things, so we can just label that 1, 2, and 3. All right, and so the key thing to know here is that when you have wedges, right, so a wedge is an up bond, a dash is a down bond. So as long as we can identify up and down bonds, we can convert from perspective to chair. The wedges and dashes tell you nothing about axial and equatorial. They do tell you about cis and trans, right? You can say that these two groups are cis and those two groups are trans. Right? They do not tell you about axial and equatorial. That's why you have to draw the chair conformation. So we have a chlorine up at 1. That's going to be up axial. We have a methyl that's up at 2. That's going to be up equatorial. And again, we know that because if you fill in the H, that one is clearly down in axial. And then we have a methyl that's down at 3. That's going to be down equatorial. And again, fill the H in. That's up axial. Right, so here we have up, up, and down, which is exactly what we have in our perspective drawing. Now we can do the ring flip, right? And again, carbon 1 is going to come down, carbon 4 is going to go up, right? So if we do that, and again, now we have carbon 1, 2, and 3. The chlorine is still going to be up, but it's going to be up and now equatorial. The methyl group is still going to be up at 2, but now it's going to be up and axial. And then the methyl group at carbon 3 is still going to be down, but it's going to be down and axial. Right? And then to figure out which of these is the most stable, we just need to count up the number of axial and equatorial substituents. So here, again, we have axial, equatorial, equatorial. So we have 2 equatorial and 1 axial. And over here, we have 2 axial and 1 equatorial. Right? So this one is going to be more stable because we have more groups equatorial. Right? And if you build the model, it should be pretty clear that that one is going to be more stable. All right, so anyway, I hope that this overview is going to be helpful as you work through the problems, and we'll spend some more time talking about this in class tomorrow.